Hello students, welcome back to my YouTube channel Data Shah. Today we'll be talking about partial differential equations. So in this series of the numerical solutions of the ODE, we have discussed about the ordinary differential equations. So today let's talk about the partial differential equations. Now, what are partial differential equations and what is the difference between ordinary differential equations and partial differential equations? When we talk about ordinary differential equations, one thing that you need to keep in mind, I'm denoting it by ODE. Basically, in ordinary differential equation, we use d, that is d upon dx, right? So this is the notation that we use, whereas in the partial differential equation, we use the operator del, right? So del upon del x, like this. Now, when we are talking about ordinary, we have only one independent variable. So that's important that it has only one independent variable. Whereas when we talk about the partial differential equation, there we are talking about two or more than two as well, independent variables. So it's more than one independent variable. So that's the difference between an ordinary differential equation and a partial differential equation. So for example, if you remember, we have taken many examples here, like dy by dx is equal to 1 plus y square, right? So y is a function of x, y is the dependent variable and x is the independent variable. And this is how you could see the partial ordinary differential equation example. Whereas for a partial differential equation, you could refer to del u upon del x plus 3 times del u upon del y is equal to 4xy. So like this, you could get the example of the partial differential equation. So that's the basic difference between the both. So now I'll be talking about the classification of the second order differential equation. So let me first of all write down what is the general linear partial differential equation. So the general, let me just write down. The general linear PDE of second order, when we are talking about the two independent variables, where we have two independent variables. So it is of the form a times xy del square u upon del x square plus bxy del square u upon del y square. So you would notice this is of second order, and then we could have, okay, this is del x del y by mistake. Oh, sorry. Then cxy. Let me just write it in a correct way. Wait a second. So, okay. So now this is a times plus b times del square u upon del x del y. So this is del operator, right? So that's used for the partial differential equation. C times del square u upon del y square plus d del u upon del x plus e del u upon del y plus f of U is equal to G. Now you would notice here what are A, B, C, D, E, F, G. So these are basically where these all are these are the functions of X and Y. So this is the most important equation that we were talking about. So let me just highlight this. Great. Now, so this equation now classified to parabolic, elliptic, and hyperbolic differential equations, partial differential equations, and we have a specific condition for that. It could be that it is also written as, I'll just write it as a or, because this can also be written as a del square u upon del x square, del square u upon del y square, del x del y, plus c del square u upon del y square, plus a function of x, y, u, del u upon del x, del u upon del y is equal to 0. So here again, a, b, c are the functions of x and y. So these are the two ways in which you can find out the general linear partial differential equations of second order. Now, our main aim is to classify them into parabolic, elliptic, and hyperbolic. So let me just consider. So I'll be taking any of the equations you can take, because here we'll be only considering the coefficients of A, the coefficients A, B, and C. We are not into what is D, E, F, G in the first equation, or maybe this function that we have written. We doesn't need this. So So let me just do the classification. So now we'll be talking about the classification. So in the classification, so such a PDE is said to be elliptic. In the first, we have elliptic. Then we'll be talking about parabolic. Then we'll be talking about hyperbolic. Great. So now for the elliptic, we have the condition that delta, that is b square minus 4ac, must be less than 0. The sign should be negative. Then that particular equation is said to be elliptic partial differential equation. Now, if this delta is equal to 0, then it becomes parabolic. And if it is greater than 0, then it becomes hyperbolic. So these are the three conditions that we'll be checking in our equations. So let me just highlight these. Great. So let's check out certain questions. We'll be checking certain simple equations, PDEs, where we could easily find out this that is delta, that is b square minus 4ac. Very easy to identify. So let's see certain questions related to that. So you just, the question would be classify the partial differential equations, right? So the classification is the only question. So let me consider the first part. So This is twice of this plus 3 times del square u upon del y square equal to 2. Now, very easy and simple to, you can compare it with the general linear second order equation, as you could see this one, or might be this one, right? So it is related to these equations only. So when we'll compare, okay, so on comparing with the general second order PDE, we get that A is equal to 2, B is equal to 4, and C is equal to 3. Now we'll be calculating our del, that is B square minus 4AC. So that's 4 square minus 4 times 2 multiplied by 3. So we are getting this as 16 minus 24. So that's equal to minus 8. That's less than 0. So that is our del is coming out to be less than 0. So according to these three conditions that we have, we are getting del to be less than 0. So this implies that the partial differential equation is elliptic at all the points. So I'll just, yes. Thus, the given, the PDE is elliptic. The partial differential equation is elliptic type. On the similar basis, we can classify the partial differential equations. So let me consider the second example here. I'm taking simple examples right now, and then after that, I'll be taking the example in which, in the next lecture maybe, in which I'll be taking conditions. That means we have the conditions on the region. So let me consider. So this is our second order partial differential equation. So you would notice in this one, you have A, B, C. This is your D, E, F and G are missing, as you could notice here. So this is what we have. So here A is the coefficient of del square U upon del X square. So that is 1. B is the coefficient of del square U upon del X del Y. So that's 4. C is the coefficient of del square U upon del Y square. So this is what all you need. Okay. So here let us calculate del. So sorry, this is B square. So we are getting this as, so here you would notice I'm getting del is equal to 0, right? So in this case, because our B square minus 4AC is equal to 0, that means it is parabolic type. So thus the PDE is parabolic. So very simple and easy. And let me take another question in the same fashion. The pattern is same. We are checking what is A, B, C, and then we'll be finding out this is the next. Now you would notice that here we are not getting, we are not having X and Y, but we are having X and T. So in this particular example, what you need to understand is here, this is just for your understanding, that U is a function of X and T. And how would you understand that? Whatever you are getting in the denominator, right? So it is del X del T. In place of Y, you are having T. So u becomes a function of x and t. So the two independent variables that we have are x and t, and the u is the dependent variable here. So this is what you need to understand. Now, here a is the coefficient of this. So that's 1 plus x square. B is 5 plus 2x square. C is 4 plus x square. So I'll just write here, this is the coefficient of del square u upon del x square. This is the coefficient of del square u upon del x del t. And this is the coefficient of del square u upon del t square. So whatever independent variable you are having, might be z, y, x, whatever. Now, calculate b square minus 4ac. So 5 plus 2x square whole square minus 4 times a and c. Now, we all know what is a plus b whole square. So let me just write it. 25 plus 4x raised to the power 4 plus 2ab. So this would be 20x square. Now let us calculate this one as well. So this would be minus 4 times 4. Now, let us, sorry. So here you would notice this is 5x square. So I'm getting this as minus 20x square. This is minus 16. And this is minus 4x4. So here these cancels out. So I am only left with 25 minus 16, that is 9. Now, as del is greater than 0, because 9 is greater than 0, right? So the PDE is hyperbolic, because our b square minus 4ac is greater than 0. So this is what we need to check whenever we have the question. Classify the partial differential equation in hyperbolic, parabolic, and elliptic type. And in the next lecture, I'll be talking about the classification, but when the region is given to us, how we could find out. So this is it in this lecture. So thank you so much.